to talk today about infinite limits. And when I'm talking about infinite limits, I'm talking about the case when your y values get really big, not your x values. So not as x goes to infinity, but what happens when y gets really big. So if the values of f of x increase without bound as x approaches a, then here's what we say. The limit as x approaches a of f of x equals infinity. Now this is a bit of a hand wave because the limit, it's supposed to equal a real number. Infinity is not a real number, but this is just a shorthand. Okay, so it also might be that the limit as x approaches a of f of x equals negative infinity, right? If your function is going in the negative direction. Okay, we will need to look at infinite limits from both the left and the right sides separately. If the two sides match, meaning they both go positive or they both go negative, right, then we can say, or we will say, the limit equals infinity or negative infinity if they both go negative. But if we get the case that one goes to positive and the other goes to negative infinity, then we'll say the limit does not exist. So if you have a graph, right, it's going to make intuitive sense. So a graph is a really great way to go with these. You can do a table for sure. The graph is just, it's a little bit easier. I'll show you a table though, don't worry. So let's look here. I've got a function drawn, and this sure does look like, I'm pretty sure this is f of x equals 1 over x minus 2 quantity squared. Okay. So as x approaches 2 from the right, so remember how that, right, here's your notation for a one-sided limit. The little plus says from the right, so go ahead and hop on your graph to the right of 2 and start walking towards 2, right? And you start getting bigger and bigger and bigger, right, till you go off the graph. So that is a positive infinity. Okay. So now we'll do the same thing. We'll take the limit as x approaches 2 from the left. So you go where x, right, is a little bit less than 2 and start heading in the 2 direction. And we're also going toward, right, my y values are going towards positive infinity. So in this case, since they're both positive infinity, what I would write is the limit as x goes to 2 of f of x is positive infinity. You do not have to do the pluses for positive infinity. I'm just emphasizing. Okay. All right, so let's take a look at this next one. And I think this one is, right, f of x is 1 over x minus 2. No squared. So let's do this again. What's the limit as x goes towards 2 from the right? So hop on the right side. Sorry, walking that way. And right, we're getting big without bound. Hop on it to the left. Right, limit as x approaches 2 from the left. My y values are decreasing without bound, so they're getting super big but negative. So since, right, one's going to positive infinity and one's going to negative infinity, right, if somebody asks, well, what's the limit as x approaches 2, right, we don't really have a direction to give anybody. It doesn't go to any one place. So we would say this does not exist. All right, let's go ahead and take a look at these two down here on the bottom. And then I'll show you a table for these guys. So if we have an equation, we'll need to look at x values near a on both sides, either with a table or a graph. Determine the left and right limits for the functions below. Okay, so f of x equals 1 over x plus 3 quantity squared. And we're going to approach negative 3 from the right. So I need to do a quick little number line. I'm going to do this with a table, okay? So, but I need a number line because I do. So negative 3 from the right. So that means I'm over here headed in. So that means I would maybe, my table of values, make sure I'm still on screen there, I would pick something like a negative 2.99 to plug in there and see what we get. Okay? And I think we can even do that one in our head, right? If x is negative 2.99, so negative 2.99 plus 3 squared. So that's going to be what, 0.01 squared in the denominator. So that's 1 over 0.1234, I believe, or 1,000, 10,000. Oh my gosh, that's really, really big, right? I'm willing to be off by an order of magnitude since I did that quickly in my head. Okay, but that sure does look like positive infinity, right? And if we got even closer to -3 on the right-hand side, this would be even bigger. Okay. Now, how about if I head towards -3 from the left, right? So now I'd be here marching in. So maybe that one would be -3.01. So what is that value going to be? Right. Again, you can punch it into your calculator if you would like. I think I will just to be on the safe side. 1 divided by parentheses -3.01 minus 3 squared. Oh, plus 3. That's why I was like, hold on. That's not the number I'm looking for. There we go. 10,000. Awesome. Okay, so also positive. Oh, that squaring. That made them both positive. So then we can say the limit as x goes towards -3, positive infinity. So I know that this graph has a vertical asymptote. So vertical lines are x equal, and the vertical asymptote is x equals -3. Okay, so let's do g of x, and I'm pretty sure I intended that not to have a squared on it, but that's okay. We'll do it with the squared because that's what I have written. And let's go ahead and look at this one with a graph. So I'll go ahead and put my calculator back up, which means I need to move my paper so that you guys can see it. So I'm just going to input g of x into my y equal screens. So here we go. I've got -5 divided by x minus 5 squared. I'm sure I've got a weird window. Yeah, it should be okay. Uh-oh. My calculator skills are just not great today. What did I do wrong? Oh, I didn't get my 5 in there. There we go. Whoop. And oh gosh, okay, it looks like as I head towards, can you see the graph okay? As I head towards -5 on the x, right? So I'm walking towards -5 in the x's, right? Negative infinity. So I'm just going to write that on my paper. The next limit, as x approaches 5 from the left. So again, you're walking along the x's headed towards x equals 5 and right back down to negative infinity. The sound effects help. So altogether, the limit as x goes to 5 of g of x, these two are the same. So we can say, doesn't matter how you're headed towards 5 on g of x, you're headed towards negative infinity.